Welcome to all of you. Today we discuss 2022 semester 3 question paper ACCA1 C programming language. This is the question paper Mathematics Honors ACCA1 C programming language, full marks 80, 2022. First question, get.ch is defined under the header file option 4 conio.h. 1b, the output of the following code is this 15. This integer is c, a equal to 10, double b equal to 5.6, c equal to a plus b, print percentage d c. So here a is in integer mode and b is in double mode. So this is the mixed mode. So this is the integer plus double mode. So here c is in c is in 15, a is integer mode and c is also integer mode. Yes, c is also integer mode. So c actually result is 15.6, but c is in integer mode, so result is 15 here. So option is option 1. How many times ACCA be printed in the following program? Int main, int I n, integer n for n equal to 1, n less than equal to 30, n plus plus, print f ACCA return this. Obviously n is less than equal to 30, so ACCA print 13 times here. So this question ACCA1 this is 13 times here. Option is 1. Next question. D. Arrange the operators according to higher to lower order precedence. This logical and percentage sign greater than equal to sign and increment operator. So here question 1D answer is 3. First is increment operator, then is percentage sign, and then greater than equal to and logical and. So correct option is this, because this order of higher to lower precedence of this option we can explain clearly. This website tutorials point, this is the postfix plus plus left to right, this unary operator and this by this multiple operator, additive operator, greater than equal to, less than, greater than equal to, less than equal to, and logical and so from this chart you can easily find this. So correct option is 3. Next question is times how many times uh, will the following loop execute for j equal to 1, j less than equal to 10, j equal to j minus 1. So first j equal to 1, next increment j is less than equal to n, yes, j equal to 1, and then decrement j is j minus 1, so this less than 0, so this 0 obviously less than 10, so these loops uh, execute for forever. J equal to j minus 1 with initial value j equal to 1 will go infinite. So option 1 is forever. Next question, the output of the following C code has included stdio.h int main integer n equal to 2, integer k equal to plus n, printf percentage d \n, comma k. So here integer n equal to 2, then this is the plus in, this is the pre-increment operator. So pre-increment means n equal to n plus 1 and then assign the value k of the value of n, so k equal to n plus 1. So run this problem, output is 6. Here plus n, 2 plus 1 is equal to 3, plus and then k equal to and now n is 3, so 3 plus 3, this a plus n is 3 plus new value of n is 3, so 3 plus 3 is 6, so output is 6. Correct option is 1, 6. Question G, what will be the output of the following C code? Void main integer x, y equal to 5, z equal to 5, x equals to y equals z, print d percentage d x. Obviously this equals means here y equal to 5 and z equal to 5, so 5 equals to 5, so it is true, so we can get 1. Question this 1g, output is 1. If we compile this, output is 1, so correct answer is 1. Because y equals to z, it is true, because 5 equals to 5, so it is true, so x equals to 1 here. Maximum number of elements in the array declaration integer a 5 8, two-dimensional array 5 8 is 40, because the total number of elements in a multi-dimensional array can be calculated by multiplying the size of all dimensions. So here a 5 8 can store 5 into 8, So this is 40. So these are A00, A01, A07, and for the second row A10, A11, A17. So for this five first row, the first component runs from 0 to 4, and for 8 second component runs from 0 to 7. So 0 to 7. Which is the correct way to initialize the array structure? So integer ARY4, this initialization 10, 20, 30, 40, and this is the correct answer. But second option is wrong because here the first bracket is here, and third is also wrong because here is third bracket and here is first bracket. And fourth option is also wrong. This is the both are first bracket here. So correct option is 1. Is syntax of one-dimensional array because we know that this data type here in integer type, and next variable name, array name, third bracket, array size. Here array size is 4 within third bracket, equal to within second brackets this value 1, value comma, value 2, comma, value n dot dot dot. So here 10, 20, 30, 40, this array 4. So array 0 is 10, array 1 is 20, array 2 is 30, array 3 is 40 here. Next question J, what will be the output in the if the following executes? Intimate character array 7 net working, printf percentage s array. Here character arr is a string variable. Here 7 characters is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So actually this is the wrong question. If we compile and run this question here, integer main character array networking, here string 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 contains 10 characters. String question, string here. So if we compile and run here, obviously this is the warning. The initialization string for the array character is too long because here is 7, only 7, so 0 to 6, 0, 0, 1, 2, 3, 4, 5, 6. So actually in this compiler output is network, but actually this is the wrong question. Dimension is here at least 10. If we put here 10 in place of plus 7, in place of 7 we 10, then compile this and run this. So obviously this is the output is networking, clear. But here dimension is 7 here. So actually this is the wrong question. Next question 2. What is a variable in C? Distinguish between local and global variables, giving examples. 2 plus 3 marks. What is variable in C? Distinguish between local and global variables. What is variable? A variable in C language is a memory location with a name that stores data and retrieves it when required. So it is the memory location with a name, and this it stores data and we can retrieve it when it is required. And types of variable: integer type variable, float type variable, and character type variable. So single character type variable with single quote, and this float type variable, this is the with decimal points, floating number, real number, and integer type is the whole numbers without decimal point. And general rules for naming the variables are: variable names can contain letters, digit, and underscore sign. And names must begin with a letter or an underscore. Names are case sensitive, so is the uppercase letter and the lowercase letters are different here. Names cannot contain white space or special characters like exclamatory sign, hashtag, percentage, etc. And reserved words, that is keywords such as int, float, break, continue, cannot be used as names. And the syntax of the variable is data type, either in integer or float or character, and the variable name equals to the value of this variable and semicolon. And defining multiple variable is data type, variable name 1, comma, variable name 2, comma, dot, 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 up to variable name n, semicolon. Example, a is integer type variable equals to 5609, semicolon. Float type variable b 9.0321, and c is the character type variable, is the character x character. Next question, distinguish between local and global variables. Given examples. What is the local and global variables? First, we consider this example. This is the integer a equal to 100. This is the global variable a. The void function, I construct a function, this void function, integer a equal to 200. Within this function, FUNC, this a is the local variable a. Print the local variable a, this. And the main program, integer main, and we call the function. So after calling this function, this print the variable a equal to 200. And next command printf global variable, this a equals to percentage d, this a. So here a equals to 100 because it's global variable. So the value of a is not changed in the global variable. So after compilation and run, local variable is a equal to 200 because we call the function this FUNC function. So here function in this function printf local variable equal to a. So here where a equal to 200. But in the next line, when we call printf global variable a, then the global variable value of this equal to 100. So print is here a equal to 100. Next, the difference between the local variable and global variables. And the scope for the local variables, they can be accessed within the function in which they can declare local variable. Global variable, they can accessed from any part of the program. Lifetime, these are created when the function is called and destroyed when the function returns, obviously. And point 2, they have global variables have a longer lifetime and exist throughout the life of the program. For local variable, memory is allocated on the stack, whereas for global variables, while memory for global variables is allocated in the data segment of the program. And the default values of the local variable don't have a default value and contain garbage values until initialized, whereas global variables are automatically initialized to 0 by default, initialized to 0. Initialized to 0 by default. So this is the difference between local variable and global variable. Next question, write a C program to find all roots of a quadratic equation with real coefficient. So this question 5, marks 5. Here the quadratic equation A, B, C discriminant root 1, root 2, real part, imaginary part. Enter the coefficients A, B, C. Obviously, A is not equal to 0 and ax square plus bx plus c equal to 0. The is the fruit type A, B, C. Scanf discriminant b square minus 4ac and condition for real and different roots. Discriminant greater than 0. There are two distinct real roots, root 1 and root 2. Print this root. Next condition for real and equal roots. So discriminant equals to 0. Root 1 equal to root 2 equal to minus b by 2a. If roots are not real, complex, else that means this discriminant less than 0. Real part is this and imaginary part is this. And printf real part, imaginary part we get. So if we put here a equal to 4, b equal to 7, c equal to 9, so 4x square plus 7x plus 9 equal to 0, we get the complex root, root 1 equal to this and this. Now for testing, we compile this for question number 282. In the Xcode question 282, this is the include studio.h and this in the Xcode for MacBook, else if discriminant equal to 0. Now question 2a, question 2a quadratic equation. Hypotenuse question 247 call question to local variable quadratic equation. This let compile, run and compile this. Coefficient, enter the coefficient, say minus 1, so 4.5, then 9. So here root 1 and root 2, this minus 1.5 and this. Next question 2b. Number 1, distinguish between the function call by value and call by address. 2 plus 2, marks 2 plus 2. And next question, write a C program to test a number is prime or not, question marks 6. Next question, call by value and call by address, difference between these. First we consider this example, call by value. Here construct a function void swap integer x, integer y. Here x and y are called formal parameters of the function swap. Formal parameters or formal arguments. Integer is temporary integer variable. Temporary variable is equal to x equals to y. We interchange this value, and y is the temporary variable. Printf and output for the call by value. Print the inside the function swap. Printf value of ab copied to xy respectively, and then change inside the function x equals to %d and y equal to %d, this x and y. This is the swap function. This is the formal parameter, and the main program integer AB. Here AB is the actual parameter, actual argument, the main. Here A equal to say 100 and B equal to 200. Swap AB. So we call the function and interchange the value A and B by calling the swap function. So printf the print the main method by call by value, and the value of A and B not changed in the main method. Printf n equals to A equal to this, B equals to A and B, return this. So when we call this, first we run this program. This is the output call by value. So the print inside the function, first we here swap, call the function swap AB. So values of AB are changed, interchange. Here A equal to 100 and B equal to 200. So here x equals to here swap A and B. Swap here A and B means x. Here x equals the first function x 100 and 200, interchange this, so 200 and 100. So x equals to 200 and y equal to 100. And next, by this printf, print the main method, print the main method call by value. The values of A and B are not changed in the main method. Here A equal to this value of A and B. So call by value, this value is A equal to 100 and B equal to 200. So here by call by value, so actual value A are not changed in the main method. A and B are not changed, actual parameters not changed in this main method. So this is the call by value. And next, call by value, here the call by value, the actual argument are copied. Actual argument means here A and B are copied to the formal parameter. This formal parameter here is x and y of the function, and the function uses, swap function uses the values in the formal parameter and not the actual parameter AB. Therefore, the original values do not change. In the above example, there are two integer values in the main method as A and B. The swap function gets these two values inside the function. The A value is copied to x and B value is copied to y. Thus, x equals to 100 and y equal to 200. And inside the function, the temporary variable helps to swap these two values. And then x equals to 200 and y equal to 100. After executing the function, the control passes back to the main function. When printing A and B, it prints the original value, that is 100 for A and 200 for B. Thus, this is call by value. In this, the actual value does not change, but the change only reflects the inside the function. This is called the call by value. Next, come to the call by address. Consider this example, swap integer star x and integer star y. Here pointer variable x and y here, and this integer temporary variable temporary equal to the star x equals to star y, star x equals to temporary variable. And here print the inside function, and address of A and B are copied to x and y. Here A equal to 100, B equal to 200, and swap the ampersand A and comma ampersand B. So address of A and B by this ampersand A and ampersand B, and copied the address to the xy respectively, and then change the inside the function. So, and call the swap this and print the main method. The values of A, B are also changed in the main method. Here A equal to D and B equal to D. And call by address, here interchange by swap x equals to 200, y equal to 100, and also change A and B also, A equal to 200, B equal to 100. Call by address is this, by this pointer technique, pointer method this. So call by address, the another name is call by address or call by pointers, pointer variable here x and y. And call by address method copies the addresses of the arguments into the formal parameters. Formal parameters, this means x and y. And the function uses the address to access the actual values. Therefore, the changes made inside the function reflect the original values. In the above example, there are two integers in the main program as a and b. The addresses of a and b pass to the function, and the function gets these addresses. The temporary variable helps to swap the two values as the function operates on the actual values using the addresses. The changes inside the function are visible in the main program. Therefore, even though the actual a and b values are 100 and 200, now a value is 200 and b value also 100. So, difference between the call by value and call by address. Call by value, this is the way of passing arguments to a function by copying the actual values of the arguments into formal parameters of the function. Actual values of the arguments were into the formal parameters of the function. Whereas call by address, we are passing arguments to a function by copying the address of the arguments to the formal parameters of the function. Number two, values of actual parameter copy to the formal parameter of the function. Whereas address of the actual parameters copy to the formal parameter of the functions. And number three, does not affect the original values by the call by values. Whereas call by address affects the original values. These are the differences between the call by value and call by address. Write a C program to test a number prime or not. This is the program. Here in I integer variable and flag is also integer variable initialized by 0. Enter a positive integer. Scanf n. Put here n, value of n. If n equals to 0 or n equals to 1, here 0 and 1 are not prime numbers, so change flag equals to 1. Initially flag equal to 0. If flag equal to 1, variable flag equal to 1, then non-prime number. Now we construct a for loop for I equal to 2 and the test condition I less than equal to n by 2 and increment plus plus I, that is I equals to I plus 1. If n modulo division I equals to 0, that means n is divisible by I. So n is not prime, so flag equal to 1. And change flag 1 for non-prime number. So here n by 2 means because the divisors is less than equal to n by 2 for any numbers less than this. If flag equal to 0, printf this number is a prime, else printf is non-prime. So compile and run this program. Input a integer 347. 347 is a prime number. Next, enter number, say 34890 is not a prime number. Question 3a, write down the classification of the flow control statement in C language. Explain any one statement with proper example. Flow control of this. Classification of flow control statement in C language. Explain any one statement with proper example. In C programming, a flow control statement is a statement that alerts the flow of execution of a program. We use flow control to make decision, repeat action, based on the certain condition. There are three main types of control statement in C: if statement, selection or conditional or decision or branching statement. If statement, if else statement, if else if statement, nested if else statement, switch statement. And number two, iteration or looping or repetitive statements: for loop, while loop, do while loop. And jump statements: break, continue, and go to. Now we discuss here, explain any one of the statement with proper example. Here iteration statement, here for loop, while loop, and do while loop. This for loop, the syntax of the for loop is for first bracket start, variable initialization, semicolon, condition, semicolon, variable update, first bracket close. Second bracket start, statements, semicolon, second bracket close. This is the flowchart of the for loop. Start for loop is initialization by this variable initialization. Check the condition. If it is false, so end of the loop for loop. If it is true, execute the statements within the second bracket, and next update the variable this I increment or decrement or other condition, this increment or decrement of this, next, and go to the condition, and so on. Example of for loop, say integer I. For I equals to 10, I less than equal to 20, I plus plus. Print percentage di, return 0. So I equal to 10. So initialization I equal to 10, and condition check this 10 is less than equal to 20. Yes. Then execute the statement this printf. So print 10. And next I equals to I plus 1. So 10 plus 1 is 11. And 11 is less than 20. Yes. So, and so on, and up to print the 20. While loop. While loop is the syntax is this, is the entry control loop. While first bracket, within first bracket condition, second bracket statements, semicolon, second bracket close. This is the flowchart of the while loop. Initialization of the iterator. Check the while condition, this condition. If it is true or yes, execute the statement, here this, and increment and decrement iterator, and then again check the condition. If it is false condition, then exit from the while loop. Example, integer n, printf, enter n. Scan the value of n. Character variable names 30. Is the correct name is the character variable with one dimensional array up to 30. Name 0, name 1 to name 29. Printf enter name. Scanf percentage is name. While n, checking if n is non-zero. If this while n, because if n is non-zero, then execute this loop. Printf percentage is name. N equals to n minus 1, and this return 0. So enter 4. Here we compile this and run this program. Here n equal to put enter 4. Enter name Onimus. So check this first name dimension. This is the string variable, then 30 up to 30 as character. So this is the Onimus ANIMESH. So here 1, 2, 3, 4, 5, 6, 7. This enter name. While n is 4, so n is non-zero, so print this, print the name. Next 4 minus 1, here 4, 3, so again print the name. 3 minus 1, 2, non-zero, again print the name. This is the 4 minus 1, sorry, 3, 2 minus 1, again print the name, and in this way the 4 prints 4 times the name Onimus. Next, third loop, do while loop. It is a form of an exit control or post-tested loop where the test condition is checked after executing the body of the loop. This loop will always be executed at least once, no matter what the condition is. Syntax: do, second bracket, statement second bracket close, while the condition within first bracket semicolon. So flowchart of the while loop, do while loop, we start, initialize for loop counter, body of the loop, update the counter, while condition in the end of the um, do loop, while condition. If while condition is true, then again and go to the loop and this way. And if false, then stop, exit from the do while loop. Consider an example. Integer I equal to 10. Initialize the integer variable I. Do equal to print percentage d I. I equals to I plus 5. So initially I equals to 10. So I plus 5. So 10 plus 5, 15. So then first print 10. This print 10. Then value of I is 15. While I is less than 30. Yes, 15 is less than 30. Yes. So again print this. Print the value 15. So print the 15. Then again I equal to 15 plus 5, 20. 20 is less than 30. Yes. So again continue the loop. Print the 20. 20 plus 5, 30. Print the while 30, 25 is less than 30. Yes. Print this. 25 plus 5 is 30. 30 is less than 30. No. So break the do while loop. So here important character of the do while loop is the exit control or post tested loop, or the test condition is checked after execution of the body loop. This loop always be executed at least once, no matter what the condition is. At least once, always be executed at least once, no matter what is the condition is. Next question 3A2. Write down C program to find the area of triangle if the triangle is formed by 3 line segment. Marks is 4. Area of triangle is formed by 3 line segment. Here integer variable side 1, side 2, side 3, and the ace is the half perimeter, and area initialization is 0.0 and the half perimeter is equals to 0.0. Enter the 3 sides of the triangle. Scanf is the integer value side 1, side 2, side 3. A triangle is valid if the sum of its 2 sides is greater than the third side. So if side 1 plus side 2 greater than side 3, and side 2 plus side 3 greater than side 1, and side 3 plus side 1 is greater than side 2, then it is a valid triangle. In half perimeter, side 1 plus side 2 plus side 3 whole divided by 2. Area is the square root of ace into ace minus side 1 into ace minus side 2 minus ace into side 3, and print the area of the triangle. Else print if it is an invalid triangle. Rectify the length of the 3 sides. So here we enter 3 sides of triangle 5, 7, 9. It is a valid triangle. Area of the triangle is 17 point something square unit. Next question. What is difference between user-defined and standard library function in C? Explain with the example. User-defined function and standard library function. User-defined function. A programmer creates a function which is called user-defined function. A function which are already defined in the C library is called library function, standard library function. User-defined function is a part of a program and is not compulsory to use in a C program. But standard library functions are the part of C header files, stdio.h, math.h, and need to use in every C program, printf, scanf, and etc. etc. Number 3, a programmer defines a function at the time of the writing the code. Developer in the C compiler predefines the library function. It's already defined here. Number 4, the names of any user-defined function can be changed easily, but we cannot change or modify the name of the library function. Example of user-defined function, say multiply numbers, my function, etc. Examples for standard library function is this printf, square root, string copy, and etc. etc. Here, an example of the user-defined function. See here, this double area circle area of the circle, double variable, double radius. Radius is double variable. Double area pi equal to define 3.14 pi r square. Radius is the pi into r square, radius into radius, return area. Double r equal to 0, initialize r equal to 0 and result equal to 0. Printf enter the radius r, this result equal to area, call the function area circle, this r, area of the, this is the square foot of the image, this. So enter the radius r, 5, the area of the circle is 74, 8.5 square unit. Question 3b2, write a C program to evaluate the value of function fx for x equals to 1 to 10 using the subprogram where fx is given by fx equal to x square plus 5 if 0 less than equal to x less than 5, fx equals to minus 2x plus tan inverse x if 5 less than equal to x less than 10. But here for this 10, for when x equals to 10, there is no definition here. Fx is only 5 which is less than equal to x less than 10. But here fx for x equals to 1 to 10. So x equals to 10 is important. Here for x equals to 10, fx is not defined here. So we define a function, float type function. Argument is x, which is also float type. FUNC function is the function user defined function. And float value is equal to initial value 0.0. If 0.0 is less than equals to x and x is less than 5, the first condition 0 less than equal to x less than 5. So this val equals to x star plus 5 because x square plus 5. For the single line statement, we can omit for second bracket braces for the if, because this only single line statement under if, so we can omit this second bracket. And else if 5 is less than equals to x and x less than 10, value equals to 2 star x plus a tan x. A tan x means the tan inverse. A tan x, return the value. Main program, float I v, float I equals to 1, I less than 10, I plus plus, v equals to, we call the function I. So when I equal to 1, v equals to function 1. So function 1 is this, from this, after calling this value of 1, printf this. If I equals to 10, function f is undefined because for x equals to 10, is value of x is not defined here. So after compile and run, this f equals to this, f2 equal to this, and f10 equal to this, undefined here. Question 4a, write a C program to find the sum of first in even positive integers to illustrate a function called by value. First in even positive integers. Here, void sum even integer, user defined function, argument here integer k. Integer sum equals to 0. For integer I equals to 1, I less than equals to k, I plus plus. If I modulo division 2 equals to 0, that is means I is divisible by 2, then print the I, and then sum equals to sum plus I. This is the if loop, if, and then for loop, this if condition is this, print I and increment of sum plus I, previous sum, initial sum is 0, 0 plus I, and this. Printf \n new line, printf sum equals to value of the sum for I loop. Integer main, this integer n, printf enter the value of n, scan n, printf even numbers between 1 to n, and even some even integer in function calling return 0 with this. If enter with value n equal to 20, the even numbers between 1 to 20 is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and the sum is all these even integers from 1 to 20, 20 inclusive, sum equals to 110. Next, 4a2, write down the C expression for the following function: x to the power y to the power 2 plus y into z to the power z divided by 10 whole to the power 5. And second function, cot square x plus mod of x into log of x to the base 10, number 2 plus 2. This is the x to the power y to the power 2. So power x comma power y comma z. Sorry, this is the 2 or z is the 2 x to the power y to the power 2. So this is the x to the power y to the power 2. So power x to the power y to the power 2. So this 2. X to the power y to the power 2. Power y to the power 2, and then power x to the power y to the power 2. And this power y star power z to the power z by 10, comma 5.0. So this is the power of this. Next, cot square x, this is the power 1 by tan x, comma 2. This is the cot x means 1 by tan x, plus this is the float value. So this is the f abs. F abs x star log to the base x, so log 10 to the base 10. This is log 10 x semicolon. This is the expression of this for second function. Next question B. Write a short note arithmetic operator, relational operator, and logical operator. Now marks is 2 plus 2 plus 2. Is the here previous question, power function is a predefined function present in the math.header file, and syntax of power function is this: double power double x comma double y, and log 10x means the C programming language. Log 10 function is mathematical function and calculates the base 10 logarithm function. This is double log 10 double x. If abs function math.header file, header file in C programming is used to get absolute value of the floating point number. So double if abs equals to double C. And next question, arithmetic operator, relational operator, and logical operator. Arithmetic operator or the symbols that are used to perform the mathematical operation on operators. There are two types: binary arithmetic operator and unary arithmetic operators. Binary means addition, two integers, plus, subtraction, multiplication star, division, and modulo division is this percentage sign. We calculate the remainder when the first operand is divided by the second operand. So 5 modulo division 3 gives 2. And unary arithmetic operators is increment operator, post increment, a plus plus, and pre increment plus plus a, and increases the integer value of the variable by 1. And decrement operators, post decrement a minus minus, and pre decrement minus minus a, and decrease the integer value by the variable by 1. Unary plus plus a, unary plus generally returns the value of the operand, and unary minus returns the negative value of the operands. Here Example of this binary arithmetic operator: a plus b, a minus b, a star b, a by b, and a modulo division b. Output is this. If a is 50 and b is equal to 15, then this output are this. Unit arithmetic operation for a equal to 100 and b integer variable. So b equals to a plus plus. This is the post increment. So post increment means first b equals to a and then increment of a plus 1, and c equals to 200. Printf this pre-increment d equals to plus plus c. First increment of the c, so c equal to c plus 1, and then d equal to c. And next p equal to 300. Then post decrement is this: first q equal to p and then decrement of p equal to p minus 1. And pre-decrement is s equals to minus minus r. So first decrement of r equal to r minus 1 and then s equals to r, value of r. And this y equal to plus x, unary operation, plus x returns the same value x, and the minus x minus 600. So this 500 and this x equals to return of 500. Relational operators: equal to operators, equals, it used to compare the both operands, returns 1 if both are equal or same, and 0 represents the operands that are not equal. Not equal, exclamatory sign equal to, that means not equal. The operator compares two operands and returns 1 if the both operands are not the same. Otherwise, it returns 0. Less than operator, it used to check whether the value of left operand is less than the right hand operand. Greater than operator, greater than sign, and this operator, the operator checks the value of the left operand is greater than the right operand. Less than equal to, greater than equal to operator this. So here a equal to 10, b equal to 16, and printf a equal to this, b equal to this. If a equals to b, print a is equal to b. Else print a is not equal to b. If a greater than b, print a percentage d is a is greater than percentage d, that's b. Else a is less than d. So first a equal to 10 equals to 16 equals to b. So here check first a equals to b, this a equals to b. So a equals to b. Here 10 is not equals to 16. So output for a equals to b is 0. It is false. So for this percentage d is false, so it is 0. So it is 0 is this. And number 3, logical operators. Logical operators is commonly used to control the flow of program based on the logical condition. Logical AND operator, double ampersand. If both operands are true, then the condition becomes true, that is 1. And logical OR operator, pipe sign, double pipe sign, or vertical bar, double vertical bar, or pipe signs. If any of the two operands is true, then the condition becomes true. Both operands true. Here, both operands true, then the condition becomes true. If any of the two operands is true, for logical operator, any one of the true, and one of these true, then the condition is true, that is value is 1. Logical not operator, it is used to reverse the logical state of its operand. If condition is true, then logical on this operator will make it false. Here example for this logical operator: age equal to 99. If age greater than equal to 13 and age less than equal to 19, A is 99, so 99 is greater than 13, and age 99 is less than equal to 19. So it is false, but it is true. So this is a teenager age. So here is not a teenager age, else this. And means this both operand true, then the condition becomes true. So here this true, but this is not true. So this if statement is false. So else statement. This is not a teenager age, greater than 13 and less than 19. So 99 age is not a teenager age. Logical OR operators, number equal to 100. In number modulo division 9 equals to 0, or number modulo division 7 equals to 0, print this number is divisible by 9 or 7, or percentage d is not divisible by 9 or 7, number is not divisible by 9 or 7. So 100 is not divisible by, so logical OR operator, any one of them true, then is true. This is not true, not division by 9, not division by 7. So else it is not divisible by 9 or 7. Any one of them true, then it is true. Then if logic is executed. Logical not operator, flag variable, integer variable is true. If not flag, exclamation sign flag, not flag, print flag is false. Else print flag is true, return 0. Here flag is true. Here flag is true. So if not flag, so obviously flag is false. So flag is false. So true. Printf. If if not flagged, then flag is false. Here flag is true. Not flag is true. Not flag means false. If this false, then it is true. This flag is false. But here flag is true, so flag is true here. True false, not equal to 0. True means 1. So non-1 0. Non-zero, so it is true. So it is when non-zero, then is executed, but it is 0. So this is the execute this line. Else. Next question. What would be printed on the screen if the following program is executed? Rear ij for this, j equals to this, printf this, printf this. We get this pattern, this ij, I equals to 1, I equals less than equals to 5, I plus plus, for j equals to 1, j less than equal to I, j plus plus. Printf percentage the j, and next print slash black slash n new line and return 0. So we get this output is this type. Question 5. Using for loop, write a C program to find first 20 Fibonacci numbers. Marks 5. Distinguish between higher level language and lower level language. Give examples. Question number 5. Question marks 5. First 20 Fibonacci numbers. Very important program. Here I and n integer variable. Now T1 and T2 to first and second terms of this Fibonacci series. T1 equal to 0 initialized, T2 equal to 1, and next third term T3 is T1 plus T2. And print for the first n Fibonacci numbers, enter the positive integer in, scan in, say put here 20, n equal to 20. First 20 Fibonacci numbers are this percentage d T1 and T2, 0 and 1, and next I equal to 3, I less than equal to n, I plus plus I. So T1 equal to T2. So here T1 means 0. So T1 equals to T2. T2 is that 1. So T1 equals to 1. And T2 equals to T3. T3 means T1 plus T2. So 0 plus 1, 1. So T2 equal to 1. So here T1 equal to 1, T2 equal to 1. Then T3 equal to 1 plus 1, that is 2. So print T3 is equal to 2. So first this 0, 1, 1, 2. And next up to this loop up to n. Here we put here n is the 6 and put this. If you put this first 20 integers. So execute this program and compile and run this. Enter the value 20 and this. So this is the first 20 Fibonacci numbers is this or this. Next question, higher level language and lower level language. Higher level language like C++, Python, Java, and lower level language, machine language, assembly language. High level language is programmer friendly language, whereas low level language is machine friendly language. High level language requires a compiler or interpreter to be translated into machine code. Low level language requires an assembler that would translate the instructions. High level language is easy to understand and portable from one location to another, but it is difficult to understand low level language or is not also portable. Number 4, high level language consumes more memory in comparison to low level language, whereas low level language consumes less memory than high level language. Next question, 5b1. What are the main data types in C? Explain with example. Marks 2 plus 3. And next question, write a C program to find the trace of a square matrix. Main data types. Data types specify the what kind of value can store in a variable. This is data. It's called data. There are 4 types. Main type, that is primary or basic or predefined. And this main type also can be subdivided as integer data, float data, character data. And derived type, secondary or user-defined data type, enumeration data types, and void data type. Here we discuss explain with example main data types. What is the main data type? What is the main data type in the question? Integer type, short integer, that is short. The storage capacity 2 bytes for 16-bit operating system and format percentage HD and range -2 to the power 15 to 2 to the power 15 minus 1. An unsigned short integer 2 bytes format percentage HU range from 0 to 2 to the power 16 minus 1. Integer type 4 bytes for 32-bit operating system format percentage D and range from -2 to the power 31 to 2 to the power 31 minus 1. Unsigned integer 4 bytes format percentage U range 0 to 2 to the power 32 minus 1. And long integer or long 8 bytes 64-bit operating system format percentage LD range from -2 to the power 63 to 2 to the power 63 minus 1. Unsigned long 8 bytes 64-bit operating system and format percentage LU range from 0 to 2 to the power 64 minus 1. Long integer type 16 bytes 128-bit operating system format percentage LLD range from -2 to the power 127 to 2 to the power 127 minus 1. Unsigned long, this is the 16-byte format percentage LLU range from 0 to 2 to the power 128 minus 1. Here we give an example. This is a to the power a equals to short integer, short a. This is the a is short type of integer. This is the -32768. That is the -2 to the power 15. This is the minimum value of short. Unsigned short, this B is the 65,535. That is the power 2 to the power 15 minus 1. This is the maximum value of the unsigned short. Integer type C, This is the minus power 2 to the power 31. This is the minimum value of integer. This unsigned integer type D is the power 2 to the power 32 minus 1, maximum value of the unsigned integer. Long integer E is the minus 2 to the power 63, minimum value of the long integer. Unsigned long is the power 2 to the power 64 minus 1, maximum value of the unsigned long integer type. Here, the short integer is this, unsigned short. Long integer is this, minimum value, power 2 to the power 63 is this. Minimum value of this long is this. And floating data type. This is a floating type float. Float is the 32-bit type and 6 decimal places of precision. And minimum positive float value is the 2 to the power minus 126. And maximum float value, positive value is the 2 to the power 128. This E minus 38, that is 10 to the power minus 38. E plus 38 means this into 10 to the power 38. Our format specifier is percentage A or percentage G or percentage E for exponential matrix form. And double data type. Double is the 64-bit types with 15 decimal places of precision. Minimum double for positive values 2 to the power minus 1022. This is the 2.22507 E minus 308. And maximum double positive is 2 to the power 1024 equals to 1.796 in E plus 308. And format specifier is the percentage LF or percentage LG or percentage LE. Long double is 128-bit type, is 18 decimal places of precision, and minimum long double positive value is the 2 to the power minus 16,382. That is 3.362 E minus 4932. Maximum double is this, and the format specifier is the percentage capital LF or percentage capital LG or percentage capital LE. Similarly, we can get maximum and minimum for negative values of float double and long double. Here, 2 to the power 127 maximum float for this machine in this compiler, and 2 to the power minus 149 minimum float, positive float in this machine. Actually, this maximum value depends on the compiler or machine particularly. Double value is this, and double is the power 2 to the power minus 1074 minimum double for this compiler. But theoretically, and this is the theoretical range of this. But for this compiler, particular this, and this is this. Actually, long double is not effective for this compiler. So here, value of A is the float type. So we get this maximum float type data, and the value of B is the very small value, positive value. So 10 to the power minus 45, 2 to the power minus 149 minimum float for this range, for this compiler machine. But here, minimum float value is this 2 to the power minus 126. But for this machine, 2 to the power minus 149, and can execute here this. And the value of C is the double maximum double is this type, maximum double is this. This is the double type. Double type 2 to the power 1023. This is the double type. So long double is not able to compute here. and maximum value of D is very small value near to 0. So here we put this double type for this percentage AD format, because this the exponential format is this 10 to the power minus 324 for this, the minimum positive value of the for this compiler. But the double for minimum value of this minimum positive value is the this 2 to the power minus 1022. Minimum double is the minus 1074 minimum double for this compiler here. Next, character type data is the two types: single character type and with the 8-bit for this, and for so this character variable can store 256 different ASCII code, and including the letters both uppercase and lowercase, digits, symbols, punctuation mark, and special characters like \n new line or \0 new character, null character. And format specifier for this character is this %C. And string types, the string type C program, sequence of characters terminated with the null character \O 0. The C string is stored as an array of the characters. A string of characters enclosed the double quotes, and the format specifier for string %S. Here, CH is a character variable with single quote A. The value of CH variable, character variable, value initial value is A. Print the value of CH, this A, and ASCII value is %D. %D is the integer type value for this A. So for ASCII value is the for small a is 97. And here str is string type variable. So this calculate a double quote within the double quote and value of this. Here this is the program not for examination purpose. Actually for this the actually unsigned integer minimum sort, maximum sort, maximum value, minimum value, integer type, and this. Long integer and long integer is no difference between this long integer and long integer for this compiler actually, and long integer for supercomputer can be calculated by the supercomputer long integer, but here there is no effect for this long integer here, and so on. Maximum float, maximum double, minimum double, maximum long double, minimum long double, and this. Next question, trace of the square matrix. Here the matrix is the double array A third bracket in third bracket in. Here trace is the function calculation for array. The sum diagonals equals to 0. Sum diagonal is the double variable equal to 0 initial value. Sum diagonal plus AII 1, A22, A33, and so on. And this read matrix, this integer mn size of row, size of column, and double matrix mn row wise input the matrix value. And main program is this double trace tr integer nij print the entire order of the matrix, that is n square matrix of order m, double a n by n, enter the elements of the matrix row wise, read matrix, so call read matrix function n a in number of rows, number of columns, and the matrix A means this is the matrix A, double A matrix, and then by this function we read this matrix scanf, this %LF matrix IG, and the trace equals to trace in A. N is the size of the matrix and A is the matrix n by n. So print the trace of this. Enter the elements of the matrix row wise, say 2 by 2 matrix. So 5, 6, 8, 9. Trace of this 5 plus 8, that is 14. Next question 6. Write a brief note on object-oriented programming. Write two differences between compiler and assembler. Write a C program to find HCF and LCM of two numbers 3 plus 2 plus 5. Object-oriented programming (OOP) is a programming paradigm that organizes software design around data or objects rather than functions and logic. Object-oriented programming objects are data fields that have unique attributes and behavior. Objects can contain data in the form of field. The main aim OOP is to bind together the data and the functions that operate on them so that no other part of the code can access this data except that function. OOP includes ideas of inheritance of attributes and methods. It also includes techniques such as encapsulation, abstraction, and polymorphism. These techniques can reduce complexity and isolate the impact of changes in the code. The main features of object-oriented programming are data abstraction, encapsulation, modularity, inheritance, polymorphism. Some popular object-oriented languages, including Java, C++, C#, Python, JavaScript, etc. And the two main differences between compiler and assembler: compiler translates source code from high-level programming language to machine-level language. Assembler converts the assembly code into machine code. Compilers check and convert the complete code at one time. Assembler do not convert complete code at a time. Output of a compiler is a mnemonic version of the machine code. Output of assembler is a binary version of the machine code. And compiler-based languages are C, C++, C#, and Java. And GNU assembler is known as GAS, GAS. Next question. Write a C program to find HCF, highest common factor, and LCM, lowest common multiple of two numbers. Here, main program A, B, X, Y, T, GCD, LCM. Scan two positive integers X and Y. A equals to X, B equals to Y. While B not equal to 0, T is the temporary variable equal to B, and B equal to A modulo division B, and B equal to the T, and GCD equals to T, and LCM equals to X star Y divided by GCD, and then output is this GCD and LCM. So here we put here two positive integers 58 and 28, and greatest common divisors of 58 and 20 is 2, and least common multiple of 58 and 20 is 812. Next question, 6b. What do you mean by recursion in C language? Differentiate between the recursion and iteration. Write a C program to test whether the given year is leap year or not. Write a C program to find the hypotenuse of a right angle triangle when other two sides are given. Recursion is a technique in C programming where a function calls itself repeatedly until a condition is met. The function that calls itself is called a recursive function. A recursion can be useful when same task needs to be repeated for a finite amount of time or input. For example, recursion can be used to calculate a switch or find a factorial. Example for this recursion: the unsigned integer factorial. This factorial is function, user-defined function. Integer n is the integer type. If n equals to 0, return 1. Return n star factorial n minus 1. Integer main, integer number, print the number, scan the number, factorial of this number, factorial number. So we call here factorial number, and within this function, this factorial n minus 1 again call repeated up to the condition is satisfied. So enter the positive integer to find the factorial 7. The factorial of 7 is this 5040. whether test whether the given year leap year or not. So year, century year leap year, if perfectly divisible by 400. Year is modulo division 400 equals to 0. This is leap year. Century year but not a leap year. If divisible by 100 but not divisible by 400. We'll see year is modulo division 100 equals to 0 is not leap year. And non-century year leap year if it not divisible by 100 but divisible by 4. So else if year modulo division 4 equals to 0, this year is leap year, and other cases not leap year print this. So for century year leap year, it is perfectly divisible by 400. Century year 400 but not a leap year, then it is divisible by 400 but not divisible by 400. So when a century year is divisible by 100, it is century year but not divisible by 400, so it is not a leap year. Non-century year, if not divisible by 100, it is non-century year, but divisible by 4, then this is leap year. So compile this program, enter year 2004 is a leap year. Compile again. On 1900 1900 is not a leap year. Write a C program to find the hypotenuse of a right angle triangle when other two sides are given. So hypotenuse, double par, double base is the perpendicular double variable, base is double variable. So double hypotenuse is the square root of perpendicular square plus base square, return hypotenuse. Enter the length of the perpendiculars P and B, perpendicular and base, and E is the hypotenuse. Call the function hypotenuse P and B, print the hypotenuse. So enter the length of perpendicular base 6 and 8, hypotenuse is 10 here. Next question 7AI. What is if-else statement? Explain with example. Write down C program to evaluate the multiplication of two square matrix of same order. This 2 plus 2 plus 6. If-else statement, it is a flow control technique used to decision making in program. This syntax: if this condition is in first bracket, second bracket, code executed when the above condition is true, second bracket close, else, second bracket start, code executed when the above condition is false. This is the syntax for if-else loop. Example for this if-else loop: time is 20. If time is less than 12, print good day. Else, that means time is greater than equal to 12, print good evening. So time is 20. So obviously this time is 20 less than 12 is false. So print good evening. Here output is good evening. Write a C program to evaluate multiplication of two square matrices of same order. Here A 10 10, B 10 10, multiplication 10 10, R C I J K are all integer variables. Here A and B are matrices of dimension 10 by 10, and multiplication is also matrices 10 by 10, and enter the number of rows, this R, enter number of columns C, enter the first matrix is first I loop and then J loop, scan the values of first matrix elements row wise and scan the second matrix value of the row wise and multiply these two matrices and multiplication matrix ij equals to 0 and another for k equal to 0 and we get the print the result and we get this. Enter the number of rows, number of columns, first matrix, number enter of elements, enter the second matrix elements, 2 by 2 matrix and multiply the matrix is this. Question 7b1, write a C program to find the sum of array elements by passing to a function. Create a function array sum to sum of arrays. This is the array sum. This is the float variable, float a dimension, this one dimensional array, a variable argument of this function array sum. Float s equals to 0.0, initialize value of s. For integer I equals to 0, I less than 5 plus I is equals to s plus a I, return s. Main void float result b is the float type one dimensional array, initialize value to 20.1, 30, 10.4, 25, 14.5 value of b. Then number array b is passed to array sum. This is the number array b is passed to array sum. Passed to array sum is this. So when we call array sum b is the one dimensional array, but we call this array sum b only. Print the result this. So sum of this array is we get the sum of the passing by the function, array function. Question 7bi, write a C program to use the function to sort of array of integers. Question B, write a C program to use the function to sort of array integers. Here array of integers, here function definition array of sort integer a 100, 100 and integer n is the arguments a one dimensional array and n integer type arguments. Integer ij temporary variable for I equals to 0, I less than n minus 1, I plus plus for j equal to I plus 1, j less than n, j plus plus for I greater than aj. And this sorting of this one dimensional array, this integer main, integer b, I, k, print enter k, enter the size of the array, suppose 10 numbers, 20 numbers, read array, scan these values b arrays and the function called array sort bk displaying the sorting arrays array in ascending order, we get this. So here enter k, the size of the array 4, enter the array of integers b0 54, b1 minus 98, b2 equal to 0, b3 equal to minus 234. Array in ascending order is this. Last question, write an output of the following C program. This integer a, b, c, a equals to plus 12 plus a, b equals to a plus plus, c equals to plus a, print this a, b, c. Integer abc equal to 12, so plus a means 12 plus 1, that is 13. Next line, b equal to a plus plus, the post increment. So first value of b equal to a, so a b equal to 13, and next a equal to a plus 1, increment of this, so a equal to 13 plus 1, 14. Next c equals to plus a, this pre increment, so first a equal to 14 plus 1, that is 15, and the value of c equals to a, so c equal to 15. So we get the result a equal to 15 and b equal to 13 and c equal to 15. This is the completes the question paper. Thank you.